Hi, Dr. Rapich here from Vet Triage. We are continuing on this issue of veterinary surgery from February 2022. We're going to be talking about fracture fixation. This is an in vivo study, so not in animals. This is in vivo, in vitro. And this is a double loop cerclage, resists greater loads for more cycles than twist and single loop cerclage. And for those who don't know what cerclage wiring is, we take these thin wires, place them around the bone for fracture repair, usually long oblique or spiral fractures, and we tie them in a knot once we wrap them around the bone. And so there's different knots, and a lot of these studies focus on what knot is the best. And so here you can see for A, this is the twist knot, B is a single loop, C is a double loop, and this is the crimp, which we're not going to talk about in this study, but these are the three that are mainly referenced in this study. So I'll leave that picture here for folks and I'll talk about it. So the objective is to compare the mechanical performance of cerclage secured with twist, single loop, and double loop knots subject to cyclic loading. In vitro biomechanical study using 1 millimeter wire, cerclage were loaded cyclically to 80%, 60%, 40%, or 20% of peak load, which is 8 per load level. The number of cycles until each cerclage loosened, which is residual tension less than 10 newtons, was recorded. So keep in mind this is going to become very technical. So for those who are interested, this is who this is for. And this is very important for surgery residents. Results show that all wires that failed did so by loosening. Twist cerclage cycled to 390 newtons and 209 newtons loosen within the first 10 cycles, and when cycled to 100 newtons, they loosened by 250 cycles. All twist knots loosened by untwisting. Single loop cerclage cycled to 320 newtons, loosened within 10 cycles. At 240 newtons, 5 single loop cerclage resisted 250 cycles before loosening. At 160 newtons, 2 of the 8 single loop cerclage did not loosen by 100,000 cycles. When cycled to 640 newton, 1 of the double loop cerclage did not loosen following 500,000 cycles. When cycled to 480 newtons, 3 of the 8 wires did not loosen. The conclusion, all that being said, is that double loop cerclage will be tighter and are better able to resist cycling than twist or single loop cerclage. So that's the conclusion there. So we'll go into the introduction now. Introduction. Cerclage wires are used in long oblique fracture repair to rebuild the shaft of a bone or for management or prevention of periprosthetic fissures or fractures. The success of cerclage depends on many factors. The ability of the knot to resist both a single large load and not loosen when subject to repeated smaller loads are important. Most studies have used a single load to failure and measured the peak load resisted. With this mode of testing, the square knot is superior to the twist knot. The single loop and twist knots resist a similar load, while the double loop and loop twist knots resisted more than twice the load. In most of these studies, the elongation required to reach the reported peak was greater than would be considered for clinical failure, which is often 2 to 3 millimeters. The ability of a cerclage to resist an applied load is also influenced by the tension generated at the end of tying. So the greater the tension, the greater the load that has to be applied to begin to challenge the knot. In those studies that measured this tension, the square knot could achieve very little, even when the first throw was clamped. Single loop cerclage will usually generate more tension than twist. Double loop achieves the greatest tension. An incrementally increasing short cyclic loading protocol demonstrated that twist and single loop knots formed with 1 millimeter wire loosened only after 260 newtons of load, whereas double loop resisted 666 newtons before becoming loose. Repeated smaller loads are more clinically relevant to failure than a single load. Another study used a continuous bending test system to demonstrate that notches as small as 1% of the diameter of orthopedic wire can decrease its fatigue strength by more than 50%. Another study compared the performance of twist, square, and not twist knots using 0.97 and 1.22 millimeter diameter wires. With a low cycle fatigue protocol, they were able to generate tension while tying the cerclage with a twist knot, but not with square or not twist knots. The square and knot twist knots had a higher peak load on a single pull to failure than a twist knot. For 0.95 millimeter wire, the cyclic load applied had to be reduced to approximately 30% of the peak load, 356 newtons for square and knot twist, and 156 newtons for twist, before the cerclage would not fail before 100,000 cycles. The twist knot at higher loads untwisted, and at lower loads the wire frequently broke at the bottom of the twist. All square and knot twist knots failed by the wire breaking. So the objective of this study is to compare the twist, single loop, and double loop cerclage using a cyclic loading protocol. Failure was defined as the number of cycles until the cerclage was loose, so either residual tension less than 10 newtons, or had elongation greater than 3 millimeters, or the wire broke. Materials and methods. All cerclage were formed from a 1 millimeter 18 gauge 316 LVM stainless steel orthopedic wire. The twist knots were cut and left, leaving 2 to 3 twists, and it was not bent over. So just to show you, you can imagine if you're creating this knot on a piece of bone in a dog, and this knot is going to be right underneath the muscle or skin. You don't want that knot causing irritation, right, as it rubs on the overlying soft tissue. So it's commonplace for us to leave maybe a few more loops on here, but then bend it over. There is some thought that by bending it over, you then lose some of the tension you created when you made the knot. So it's important here they're not bending it over. It may not be clinically applicable in a lot of cases, but that's why they specify that. The single loop knot wire was pushed flat to the jig and was cut, leaving approximately 1 centimeter, and then double loop knots, the arms were folded flat and then cut, leaving 1 centimeter. Okay, load to failure. 6 knots of each cerclage type were formed. Cerclage was distracted to failure at 0.5 millimeter per minute. The peak load of the knot was defined as the maximum load recorded before the load reduced to 10 newtons, or the load at 3 millimeters of displacement. In regard to cyclic fatigue testing, each knot type was evaluated by cycling a cerclage to a load that was either 80%, 60%, 40%, or 20% of the mean peak load calculated from load to failure data. Results. Load to failure. The resting tension of the twist knot was lower than for the single loop knot. The double loop knot was tighter than both the twist and single loop knots. The peak load resisted was lowest for the single loop and highest for the double loop. For twist knots, the twist gradually untwisted and the load resisted increased up to 3 millimeters of elongation, which was where the peak was recorded. Failure of the loop style knots was by unbending the arms, with loss of tension well before the 3 millimeter elongation limit. In regards to cyclic fatigue testing, again, it's going to get quite technical here. Cycling twist cerclage to 80% and 60% of peak load caused loosening within the first 10 cycles. At 40% of the peak load, so 190 newtons, all of the twist cerclage were loosed by 250 cycles. At 20% of peak load, which is 100 newtons, 5 were loosed by 250 cycles, 1 by 500 cycles, and 2 by 10,000 cycles. Single loop cerclage cycled at 80% of peak load, also loosened within 10 cycles. When cycled to 60% of peak load at 240 newtons, 5 loop cerclage resisted 250 cycles before loosening. At 40% of peak load, which is 160 newtons, 2 of the loop cerclage did not loosen after 100,000 cycles. The double loop cerclage was able to withstand the highest number of cycles without loosening. When cycled to 80% of peak load, which is 640 newtons, 5 knots loosened by 250 cycles, 1 by 10,000, 1 by 40,000, 1 knot did not loosen following 500,000 cycles. When cycled to 60% of peak load at 480 newtons, 2 wires loosened by 250 cycles, 1 by 50,000, 1 by 100,000, 1 by 400,000, and 3 of the wires did not loosen after 500,000 cycles. And I wish my only problem really with the study, other than generating more data, is that they don't show any pictures of the device or the loops like I have in the drawings down below, any of that stuff. It'd be nice to have pictures showing us what they did. Okay, discussion. All wires tied with a twist knot were still intact after 100,000 cycles, even at 80% peak load at 390 newtons. The single loop knot performed better than the twist knots when cyclically loaded. The double loop cerclage resisted higher loads for more cycles than the other 2 knots. the ability of some double loop cerclage to still have effective tension after 500,000 cycles of 640 newtons, which is 65 kilograms of load, suggests that they will be strong enough in most clinical situations. Over tightening the knot might damage the wire. However, this does not represent clinical use of wire where the wire is tied as tightly as the operator feels can be achieved. Incremental stepwise loading protocol, twist, and single loop cerclage have been shown to loosen at a similar load. As in earlier studies, the double loop cerclage resisted the greatest load. So finally, multiple studies have shown that the double loop knot is superior to both single knot and twist techniques, both from initial tension and yield load. In this study, the double loop knot also achieved the greatest initial tension and peak load of the knots tested. It has also withstood the highest number of cycles at the highest load when subjected to cyclic fatigue testing. These findings suggest that double loop cerclage is the most secure cerclage of the knots tested and would likely be the best choice for stabilization of fracture fragments or periprosthetic fissures where knots will need to resist repeated loads prior to bone healing. And there you have it. So, interesting study. We've got a few more in this journal before we move on to the next one. Thanks for supporting the channel. We'll see you tomorrow. Bye-bye.